Hello and welcome back to another episode of Math with Sohn. Today we're going to be solving logarithmic equations, but specifically the harder ones. So the harder problems are specifically going to be ones where you're going to have two logs on one side of the equation and then have to do something. So if there's a minus in between, then you're going to have to divide, but if it was a plus, we would have to multiply. If you're looking for the easier log problems, feel free to watch another video. This one's going to have some of the harder ones. So as long as they're both of a base 2, we can divide the 6 by the x minus 4, and then it will equal 1. Okay, so you combine them, and then we have essentially 1 log base 2 of this big fraction. Once you have a single log, you cannot do this until you get the single log, then you can switch this around. So 2 raised to the first power would equal 6 over x minus 4. If we want to solve that equation, 2 to the first power is just 2. So if that wasn't 2, like if it was 2 to the fifth power, I'd have to figure that out. But it is just 2. I'm going to multiply by x minus 4 and multiply by x minus 4. And then distribute the 2, because multiplying by the x minus 4 canceled it over here. We would end up with 2x minus 8 from distributing the 2 equals 6. Distributing the 2. Add 8 to both sides. Add 8. Add 8. 2x would equal 14, which means x is equal to 7. You do need to check your answer and plug it back in to make sure you're not taking the log or ln of a negative number. And in this case, we are not. 7 minus 4 is just 2. 7 minus 4 is just 3, which is positive, so that one works out. All right? So let's do a few more. Let's do a few more. Here, we have ln's on both sides. The fact that it's an ln or a log does not change much. It still is the same operation. So the big difference this time is there's a plus in between, not the fact that it's an ln, that you have ln's on both sides of the equal sign, and more importantly, this 2. That 2 is the first thing I deal with, needs to be written as a squared. Any number in front of an ln or a log is the same as an exponent. Then I'm going to write 9. So essentially I have the ln of 9 because 3 squared is 9, plus the ln of 2x minus 4 equals the ln of 18. Now the ln's will cancel out, but not until you've combined these. If you cancel them out here, you might end up adding the 9 and the 2x minus 4, but in fact, with the plus in between, unlike what we just had where there was a minus in between, you multiply. So we're going to multiply the 9 in both of these, getting the ln of 18x minus 36 is equal to the ln of 18. From here, now, because there's ln's on both sides, or logs on both sides, it could have been, they cancel out. If there's a log on one side, you have to swish it around. If there's a logs on both sides, they cancel out. 18x minus 36 equals 18. Add 18 to both sides. Add 36 to both sides. 18x would equal 44. And when you divide, you get 3. 54, 54. I knew the answer was 3, so I didn't focus on adding. So x is equal to 3. Make sure when you plug in 3, you're not going to take the log or ln, in this case, of a negative. 2 times 3 is 6, minus 4 is 2, thus saying that that is okay. All right, we got a few more. There's a lot of variants of these harder problems. All right, this one's very similar. The big difference is the fact that it is a log instead of an ln. And there are not logs on both sides, but it's going to be very, very similar. We have to start the same way by making the exponent here. And when I do that, I'm going to put the 2x in parentheses and have it both being squared. So this is really going to make the log 9 of 4x squared when I distribute the 2 to both of those. The 2 squared makes 4. The x squared is just x squared. Plus log 9 of 1 equals 3. Because there's a plus in between, we have to multiply these two things together. So 1 times 4 makes log 9 of just 4x squared. 1 times anything is just itself equals 3. Now, because there's a log on one side, not on both, they're not going to cancel. I have to get rid of it by swishing the log around. And I would have 9 to the third power equals 4x squared. 9 to the third power it's a big number. 9 to the third power is 743, I believe. 729. I was so close. So close. Not quite. 729 is equal to 4x squared. We're going to keep this as a fraction. We're going to divide by 4 on both sides and keep the 729 over 4 because it does not divide by 4 is equal to x squared. And then we're going to square root. So we get x equals plus or minus the square root of 729 is actually square root of 729. My blue calculator, 729 is 27. That's fun. So we end up with plus or minus 27, and the square root of 4 is 2. Then we have to plug it back in to the original to make sure that both of them will work. Well, 27 over 2 would work because you plug it in, it's positive. But the negative 27 over 2 would not work, so we would not be able to include that as an answer. So the negative 27 over 2 would be canceled out because it would be the log of a negative number, and that's not okay. The 27 over 2 would work and is a-okay. All right, moving right along. We're almost done. We got 2 more left. This next one is a more annoying problem. I wouldn't call it more difficult. Logs on both sides. See how we have 2 logs over here and 1 over here? They're eventually going to cancel. But there's a plus sign in between, so we again have to multiply. So we're going to multiply the x minus 2 with another x minus 2, which in this case means we will have to FOIL this out, giving us x squared minus 2x from the x times both. And then negative 2x, and then negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Well, if we combine the 2x's, we end up with x squared minus 4x plus 4 equals log base 2 of 9. Now, not 2. Oh my goodness. There's a few issues with my original problem. If it actually looked like this, you could not do this, because what is unusual about this problem is the fact that these 2 logs are not the same. They would both have to be the same for you to be able to do this. And I'm going to make this a log 7 of 9, because that makes the problem a lot easier. If it wasn't, we would have to do a lot more work, which is not something I want to get into in this video. These are the harder examples, but not the near impossible examples. Now that they're all a log 7 like I originally intended, they are going to cancel out. We are going to have left x squared minus 4x plus 4 equals 9. Because there is an x squared and an x, we need to think always with algebra. If you have an x squared and x, set it equal to 0 and probably factor. If we subtract the 9, we get x squared minus 4x minus 5 equals 0. And then we have to factor that. So we have to think what multiplies to negative 5 but adds to negative 4. Well, what multiplies to negative 5 and adds to negative 4 would be negative 5 and a positive 1. Those multiply to negative 5 and add to equal negative 4. But if those are just the factors, your solutions would be 5 and negative 1. One of which will probably work and the other one will probably not with the factoring problems. If you plug in the 5, it's okay. 5 minus 2 is 3. Last time I checked, 3 is positive, so that one works out. If you plug in the negative 1 minus 2 is negative 3. That does not work out because you can't have a negative log. It's not the fact that it was a negative 1. It was the fact that when we plugged it in, we got a negative log. That made it no work there. It would be called an extraneous solution. No. One more One more, ladies and gentlemen. Last one. This one looks like it's an easy problem, comparatively. But if you don't think ahead of time, this will break the problem. For instance, if you swish this problem around, you would get 3 to the 20th power, which will break your calculator. If you swished it in the beginning, 3 to the 20th power would equal 5x minus 1 raised to the 4th power. That it's just not going to work. I wrote it real small because I want to move it off to the side afterwards. 3 to the 20th power is what? That would probably not be something you would want to do without a calculator, and it would be ridiculous. And I thought for a second I would actually go into scientific notation because that's a really big number. What you can do is the opposite of what we did the last time, and that's move the 4 down, which we are allowed to do when there is a log only on one side. See how we only have this log right here? That would leave us 4 log 3 5x minus 1 equals 20. And because there's not a log over here with the 20, you can divide by the 4, leaving us with log 3 5x minus 1 equals 5, which is a much more manageable problem to swish around. 3 to the 5th power I can do, maybe even without a calculator, equals 5x minus 1. 3 to the 5th power is, I'm using a calculator, I lied, 243. I could have figured it out, though. 243 equals 5x minus 1. Add 1, 244 equals 5x, so x would equal whatever 244 is divided by 5. If you plug that back in, 5 times a positive number is going to be a really pretty big number. Minus 1 is going to be okay. So that one works. And we have completed all the problems. High five to myself. I will see y'all in the next one. Stay positive, everybody. Bye.